2, 3 have been dissolved in distillate process, recrystallized and annealed as a bar. Then D stands for carbonate precursor, and again recrystallized and annealed as a bar. C and D is nomenclature given for CaCO3 and dissolved in still H2NO3 nitrate. First nitrate is formed, then solution added to distill dilute H2SO4, recrystallized and annealed as a bar. That is CND. ND is a nitrate. Carbonate converted into nitrate is CD, and CND is carbonate dissolved in distilled HNO3 solution added to this dilute H2SO4, recrystallized and annealed. Then ND is nitrate. Then SND is CSO4 twice H2O dy2 dissolved in distilled H2SO4 and dilute HNO3 added, recrystallized and annealed as above. NSD is carbonate converted to nitrate and precipitated as CaSO4. Then CSSD is carbonate, then NH4 2SO4 fired at 975 degree Kelvin for 12 hours and then quenched to room temperature. Then CSSD, the carbonate oxide, then NH4 2SO4, the same procedure, initiation is carbonate. Here CND, this carbonate U2O3 dissolved in dilute HNO3, is carbonate converted into nitrate and then distilled dilute H2SO4, recrystallized and annealed at 675 and quench at 20. So U2 plus P is chlorides, and then SD is from sulfate. Means carbonate, sulfate, nitrate, precursors, and different techniques. These 14 techniques we have prepared the same, and what we have found is like this. PL groupings. Look at the green. C 1 mole, 0.1 mole percent DY2. All the samples P and CSSD, these are A type, having single peak around 400 degree Kelvin. And then sample PD and SD, and ND, SND, CND, and CNSD. These are the performances in green. So you can have this peak is more symmetrical and useful. If you go for the photoluminescence at 354 nanometer excitation, you will see that samples ND gives you the best performance. So it is for RPL dosimetry, U2 plus, U3 plus conversion by absorption of radiation one can use for. So this is what intensity relative units and value for excitation and emission for U2 plus and U3 plus. And U2 plus is the thing converted into U3 plus, that is what the radiation. The excitation spectrum and the emission spectrum, which is being monitored for getting the excitation frequency and 255. The other phosphors which are we have tried our best by 3 different particularly Gajanan Bharati, who is working at Wadi. Second one, Pankaj Delsa. He did a lot of work on TLD materials. Actually, he worked with me for a project by AERB, Atomic Energy Regulatory Board, and we have delivered two products to BRC at that time. And it is the work done by these three, four people who have put up the who have fulfilled the design criteria planned by we people under the guidance of the professor. All pink phosphorus, pink color phosphorus, LIFMG, COP, KMGF3, CF2, MGF2, then LISK, 6. All these phosphors are prepared by various methods, and best method is to identify its performance. I tell you, the phosphor which we have delivered to AERB, LIC, it has got 3.84 times performance than your LFT and as well as the CSO. The performance of the product which have been developed in this are very useful, and that will be appreciated by board, and they have given appreciation letters for technology transparency. I will give only one example here. The sulfate base, these are also going to prepare Li3PO4. All this pink color phosphor, we have got publications on either PLD or website. So we will take only one example of LICLF6. This phosphorus are prepared procedure for the preparation of different chlorides is given in self-explaining flowchart. I have not given the flowchart here. Flowchart is given at the last, and it may not be getting displayed because of different reasons. Because we are now suggesting that procedure to be patented, because that procedure is not being altered in many of the publications till then. It is treated as the first case. Starting materials, medium of reaction, temperatures of reaction, methods of insertion of dopant, drying techniques, etc., were varied from optimization of phosphorus. We have changed all these listed parameters while for getting the better performance. In the second case, the metal chlorides were used as precursors in place of metal carbonates in step 1 of flowchart to prevent hydrolysis. The rest of the procedures were the same as the case 1. The 4 different techniques are being used, and fourth one we are going to have a patent for preparation, because these techniques are also being found useful for preparation of few OSLD phosphorus, optically stimulated phosphorus. New person working on that line, and therefore we are not disclosing these techniques. This is also Gaurate's thesis, and here we have not disclosed the exact synthesis. LIFMG, LI3, LF6. These are the phosphor for TL dosimetry. C, LIF3, LIMGF3 performance. CSO4 device is much better than LIFMG. And for different dopants, DY and U and dopant, you can have higher field doping. Intensity is higher. For ALF6, LIMG, LF, and LICLF6, you will see that LICLF6 will have new dopant, the intensity fraction of all other NAM. See, the LICLF6, in that case, DY could not gain has better performance. MN also not better. But EU is literally, we are getting our TL glow peak around 200, and that is single glow peak, and which is a symmetrical one. And therefore, LICA6 performance is advisable. So we have tested this particular concentration. All parameters are being decided thereof. So this wet chemical method, very simple method by which this is being and compared, the performance is being compared with the CSO4 DY and how much percentage, 100% performance is take and other performance. See here, 230 degrees centigrade peak temperature, that four step. The phosphor which is being prepared by step 4 and the TL peak is around 230 degrees centigrade. We have got TL intensity which is 3.4 times the standard CSO4 which is being used. CSO4 is being used present in gas for personal monitoring. So this is what this is LICALF6, LINALF6, LIMG, LIL, LIMGF3. See the performance of CLF6 and typical brokers for LICALF6 prepared by various methods exposed to one. Means A, B, C, D. This B is fourth method, and we can get the input performance for the fourth one. This is for confirmation. 30-gram product is opted in a single batch, and that 30-gram batch is having exact matching with the acidity. Batch processing is also being done. So TL emission spectrum of LICALF6 at 160 degrees Celsius. And this is what typical emission and excitation spectrum of LICALF6. Then effect of concentration of U on the TL intensity of a LICALF6 is also being monitored, and as you increase the concentration of U, you can do level, we will see the performance of this, and then effect of U concentration on TL intensity. This is PL intensity, this is TL intensity, and we could get 1 million percent, around 100%. The PL intensity. PL is inconsistent. TL is active 1000 ppm here. So TL blockers of LICALF6 used for various EU concentration. If you level, E is what? 2000 PL emission spectrum for various quenching temperature variation in PL peak intensity of LICALF6 quenching temperature and quenching temperature performance variation PL peak with quenching temperature. So it's a very stable phosphor. Sensitivity as compared to CSO4 DY and sensitivity as compared to CSO4 DY is being gone gamma ray sensitivity and ray sensitivity. In both cases, you will see that the performance of the LICALF6 is much better than the standard CSO4 DY, which is being very used. So this is the X-rays and how X-ray performance goes image with gamma rays, beta rays. Those linearity with X-rays and also all these are being tested long system. This is fading of TL response of LIC or some duration. This is 500 hours step stable. Repeatability of the TL response is not being seen on LIC or 5 batches of 30 grams each. We have prepared 5 batches of 30 grams each after particular interval, and we see the performance is reusability. Reusability for the peer response. LIC for 10 cycles. The same sample which is being made at the low temperature, incredibly low temperature. The same treatment is given. Same sample is being used 10 times. This is the first one, this is the 10th we use. So reusability is also being tested, which is also being tested against OSL grade AL2. LIC6U is having lower intensity than AL2C, and ppm is the optimal concentration for U as a dopant in the LIC6. And quenching temperatures for the best product should be more than 700 degrees centigrade near to its melting points around 885. So sensitivity for the gamma rays was about 3 times more. Sensitivity for the beta rays was about 4 times more. Minimum detectable dose of beta rays was estimated as 93.66 into 10⁻⁶ kg. It gives about 2 times better response to low X-ray photons. The intensity for AUV X-rays was about 5.5 times of 1.2.5 MeV gamma rays. So it is negligible fading over a considerable period, except the early fading within 48 hours. The phosphor has only 6% loss after 1 month. Batch reusability is good. There was not more than 5% variation in the peak intensity for LIC batches. Reusability was studied for 10 cycles, and the performance variation was found less than 5%, which is between acceptable limits. Its OSL sensitivity is about 20%. However, I'm very happy to indicate here that we have also prepared OSL phosphor, which is LNPTB, which is better than even our phosphor is also better than the BRC product. The BRC has accepted, that book has accepted the LMPTB doped with boron, electron boron plus. I was supposed to give those results for presentation today, but I think that the time is short, and therefore I will, in short, I will summarize. LIC6U2 plus has not only potential to replace widely used for drug, it is precisely exhibited that it can be synthesized by a simple modified chemical method. So this is what Appendix 1, and for you I am indicating wet chemical synthesis product is. For this product, there are 4 steps, and this is step 1, step 2, step 3, and step 4. Modification in step 4 is being done here, and the flow chart is the same for. So I will not go to 3, 4, 5. Another 1.5 hours will be required for explaining. Therefore, I will go to one remark regarding human development. Why we could do those things in a better fashion only because that we got training in university led by Professor C. Monday, and the torch bearers are like Dr. S. All Dr. Sapre and other people. They have created a research culture in the department, and that research culture has benefited many things. I summarize in this way that I find that the education should be like that. The education should build the confidence among the students, which our teachers have built the confidence amongst us. And by giving, I hear, I forget, I read right, I remember. Therefore, whenever our teachers say something, write something on the blackboard, draw something on the blackboard, at the same time, we should get those diagrams and matter written on our notebook, which is being spelled out by our teacher and written on blackboard. And after coming home, we used to do homework. I do, I understand. Understanding will be done only when understanding will be effective only when I do. And if I practice, which Dr. Modi sir always used to say that you should practice those habits. When I practice, then I gain confidence. Our education was really a very nice education which has built up confidence in us. But students, today's students are having better understanding and better confidence level because of advancement in the technology. We were deprived of many techniques that time, but the students today can have many more avenues they are having. They will be still better than us. Research career should be productive. Means we should focus research activity and do research activity, which we have explained a little bit that the research should be practical, product oriented. And I think I plan, I test, I investigate, I execute, I create, and then I implement, I produce. Once I produce, then it becomes a product which is a commercial viable. And real development will be done, will be witnessed only when providers, development leads to providers. I work out, I innovate, I dedicate, I incubate, I apply, I do extension. So resources generation is nothing but job providers. So real development will be done only when we do our products Atmanirbhar, as rightly pointed out by Dr. Modi sir in his teacher in keynote address that we should be Atmanirbhar. And then only we can grow our economy, we can depend on ourselves. Everything which we are doing is only for sustainable development. And sustainable development recognizes that growth must be both inclusive and environmentally sound to reduce poverty and build shared prosperity for today's population and to continue to meet the needs of future generations. It must be efficient with resources and carefully planned to deliver immediate and long-term benefits for people, planet, and the prosperity. That is what is called as a sustainable development. Means education, research and development, and further to development is a sustainable development, which should be like this. So the Application of this SD matters, SD development, sustainable environmental, sound growth, inclusive growth, the needs of future generation, resource efficiency, long-term benefits, and shared prosperity. We have proposed the Sustainable Center for Sustainable Development for the city, 84 crores, under the guidance of Dr. Sanjay sir. And there are three branches, rather, training and capacity building, which is very much essential for research training and product-oriented planning. That is capacity with human resource development, then research and development, and then facilities. So the center should also sustain on their own income generations. This is what the concept of sustainability. This is my group, blue, green, red, and black. All black are my students. Blue, these are the students of Dr. Bhatkar. Green are the students of Dr. Inge, and red are the students of artists. And all these bold are holders and non-bold are working presently. Our talk is Dr. This is Madam has already explained these things. I will not go into detail of these. While selecting the students, selecting the subordinates, the group members, we are defining qualities which are selective. One must be dedicated, must be hardworking and dedicated work, but the person should also be cooperative simultaneously. Then only dedications will have. He should work with commitment, but only commitment is not sufficient. Commitment along with loyalty gives more rewards. One can be punctual, but looking at only the time is not useful. Flexibility is very much necessary. Punctuality with flexibility can promote people to work for. One can be intelligent but not motivated is useless. So intelligence should come with motivation. Just like discipline should come with attitude. Attitude and discipline, these are the two words. They are 100%. Promptness with a smart work. You may be prompt, but hodgepodge work and giving in time is useful. Promptness with smart work. If you are going for the smart work, the time limits can be altered. The promptness with smart work is very much useful. One should have an innovative mind that should be creative, not destructive. And systematic approach is very much necessary. But if the structure is logically organized, then systematic approach will be very much useful for both qualities which are selective and reflective should go in hand in hand. So I'm very much thankful to the organizers for giving me this opportunity and all 225 participants which are just listening to this particular lecture patiently. I am very much thankful to all participants for patiently listening, because listen and silent listening is very much important. Both words are having the same letters, but their sequence is different. So, same product can be prepared by different letters, but which step is to be adopted after a quarter step, that sequence matters. And therefore, we find the materials becomes important for given applications. Thank you very much.
Thank you very much, sir, for such a valuable and informative session. And I think it is really useful for all researchers. And I hope all participants have enjoyed this session. Now the session is open for discussion. I hand over the session to Archana Madam. Archana Ramteke Madam. Madam, please. Archana.
Yes. Thank you, madam. Am I audible?
Yes, yes. Yes, audible.
Thank you so much. Thank you so much, Omanwar sir, for such a nice information. Thank you very much. And we have so much of comments in the chat box from the participants that your session is really nice and very informative.
Okay.
Sir, we have few questions. Shall I start with the questions?
Yes, yes, yes.
Yeah, definitely.
Sir, what is the criteria and methods to design host material theoretically?
Yes, I am not getting audio properly. Yeah, please.
What is the criteria and methods to design host material theoretically?
Oh, theoretically, I am not a theoretical person, but whenever you go for designing host materials, you should see that the valencies, the cation and anion valencies are to be adjusted. And you should look for the simple structure, means the material or the product which you are thinking of should belong to the simple cubic and cubic category. Very simple lattice, so that we can have ideal level of thinking for its modification of the lattice parameters. So lattice parameters decided. You have got so many theories for deciding what is the matching of or creating post lattice, which will have the band gap of so and so. The action band should start at this level. Well, band.
Next question. If phosphor prepared by different method, then every method has different property or same of that phosphor.
No. Different method for high exhibited properties. The same phosphor is being prepared by different method. The performance of the phosphor is different. The properties, the nature of the response may be the similar, but the performance is different because of variation in particle size, because of proper incorporation of activator at a given site, because of the symmetricity, the non-supersymmetry or supersymmetry nature of U3 plus which we get. Depending on the dopant, which symmetric sites are there, how many non-symmetric sites are there, accordingly the performance changes.
Thank you, sir. Sir, next question. Would you clarify on transient metals as luminescent material by combustion method?
No, the transient metals we are considering these are sensitizers of activities. They used for transfer of the absorbed energy. Mostly the transition metals are used for this.
Sir, next question. How attenuation coefficient varies with the wavelength when energy of incoming photon is equal to or greater than band gap? Then how attenuation coefficient varies with wavelength?
Attenuation coefficient varies with
Wavelength.
of what?
Sir, it is not mentioned. When energy of incoming photon is equal or greater than band gap,
Okay.
then how attenuation coefficient varies with wavelength?
So, means whether the energy associated with the photon is more than the band gap, then that photon will be absorbed in the host line. Okay.
Okay.
Attenuation means the photon is stopped. Incoming photon is stopped. Do you mean to say it is attenuated because of what are the reasons for its attenuation? Is it so?
Sir, it is not mentioned here. Monica ma'am want to ask the question.
Mm-hmm.
Okay,
you can ask people to send me these queries on my email ID.
Yes.
So that if required, get some more information from them so that their queries can be solved with.
Yes, sir. We will provide your mail ID
Oh.
to the WhatsApp groups. Sir, I'll take the next question. What is the excitation time? Is luminescence continuous or is there lifetime?
No, the time resolved spectroscopy is to be done for that, for finding out the for how much time the electron will remain in the excited state. Okay.
Okay.
Actually, luminescence is of two types. That is the phosphorescence and the fluorescence. And if the emission occurs after some time, then we call it as the phosphorescence. And if it is 10 raised to minus 5 seconds, less than that one, we call it as fluorescence.
Thank you, sir. Sir, next question is there for dosimetry purpose, which phosphor is best?
It depends. Dosimetry, for dosimetry, what kind of dosimetry you want to go for? Like personal dosimetry, you should select the phosphor for tissue equivalence with the human body. For the material which is having that particular equivalent atomic number, then the performance of the material is very close to the performance or damage performance of the human body. So one can go for the kind of application where dosimetry is to be done. High dose dosimetry, which range particularly you want to do, or clinical dosimetry, giving cancer, giving treatment to the treatment of the cancer for the people. Where exactly, or hand or nose or whatever, means what part of the body is to be given that particular radiation. That also decides what kind of the dosimeter is to be used for evaluation of the dosage given and absorbed by the body.
Okay. Thank you, sir. Sir, next question is there. Which method is best for preparing nanoparticles for fluorides?
Fluorides.
Yes.
I am not prepared fluorides for nanoparticles. Therefore, I am not the correct person to advise on this particular line. Because most of the time, the nano materials are not prepared by me in my laboratory. Whatever I give, it is through search only. So, I am not the correct person to advise on this particular question.
Sir, similar question is for borates also. Is there any method which is best for the synthesis of nanoparticles for borates?
No, I have not tried for borates also. Borates we have prepared first by combustion technique. The particle size is more than a micron level, 1, 2, 3 micron, like that. The borates are very much critical to prepare by combustion technique. The expert person is Dr. Sonekar, who is totally worked on borates. And I have allotted the students who are working under Sonekar. All these students are also working on borate based materials. So I will advise Dr. Rajkumar Sonekar here. I request the organizers to comment on borate material synthesis by combustion method by R.P. Sodekar, if he is a participant. Because day before yesterday, Sodekar was there.
Okay. So we have another question. How OSL comparison is done between LICA, ALF6 and alumina?
It is being done at BARC. BARC group, ISSD group, Mukul Kulkarni and Soni and Soni, Bhushan Bhargavkar, these people were very cooperative, and they did the comparison. The measurements are being done by students, visited the lab, and there we have taken the performance. Means there are two machines rather, and now we have procured the machine. When LICL6 was being prepared and handed over to BRC, that time that research leader was not there. And if the research leader when I procured, we can do the analysis and comparative studies with standard samples. The standard samples are to be procured from BRC because we do not, we have not procured those samples. Even for peer measurements also, we procured those samples from Nuclear Science Center at that time. Dr. Wiltshire, who was kind enough to give us a Forshaw PL digital CL100 that we still compare all these to the commercial products. And BRC people used to help in this comparison. Our LICL6 OSL performance is very, very small, even less than 20% of your air to see.
Okay, thank you, sir. This is the last question. That if we look forward to the future, what is your opinion about the rare earth doped materials?
Future of
rare earth doped materials.
It is very difficult to get rare earths from IRE even in India. If you want to procure rare earths from hello.
Yes, sir. Yes.
Am I audible?
Yes.
I'm getting different sound.
Yes. I request other participants to please unmute yourself.
Today, getting rare earth in India is very difficult, and therefore, various the research persons who are really involved in their research at their destinations at college level, they are finding difficulties in getting the proper rare earth. And rare earth, that too of a desired purity. Indian rare earths have already stopped supplying those rare earths. It has to be imported. And most of the imports from China. And how far China products are reliable or rare earths are reliable, that one. Screen products are to be obtained for those things. But our in old days, means 1960s, 70s, 80s, huge rare earth stock was being, that is 80s and 90s. Those create more than 12 projects, and through that projects we could get rare earth materials there, and those materials are very promising rare earths. Now, the difficulties are for rare earths, and rare earths doped materials will be difficult to manage in future. But there is no alternative to that. Coif elements are all rare earths elements. Impurities are very much having different oxidation states, and theoretically and practically speaking, without rare earth, we cannot do much of research in university.
Okay, thank you so much, sir. I hope all the participants are get satisfied with the question answer session. Sir, thank you so much. We will now move on to the end of the session. I request Tulankar Madam, Professor Tulankar Madam, please continue with the session.
Thank you, sir.
Tulankar Madam.
Oh, Madam.
Thank you, Archana Madam.
Thank you.
And thank you so much, Omanwar sir. Hope sir's talk has given a deeper insight into the luminescent materials, and he has satisfied the queries put by all the participants. Thank you all for your active participation. I have one announcement to make today, and I want to share that KDK College of Engineering and Bhewapur Mahavidyalaya would be celebrating International Yoga Day tomorrow morning at 9 a.m. And we would be sharing the Zoom link for the same with all the participants. And I urge you all to please join us for the yoga session at 9 a.m. tomorrow. After the yoga session, we will meet for day 5 session of STTP at 11:30 a.m. sharp. That would be to listen to another eminent personality, that is Dr. K. Revatkar. So hope that you will all join us for the yoga session in the morning. Till then, goodbye, stay home, stay safe. Thank you all.
Thank you. Thank you. Thank you, sir.
Thank you, sir.
Thank you, sir. Okay. Okay.
Huh?
Thank you.